solve the inequality. So we have an inequality, right, denoted by that less than or equals to symbol. On the left-hand side, we have two sets of brackets, likewise on the right-hand side. And solving the inequality just means get x by itself on one side. So for example, x is less than or equal to 4. We've solved the inequality. We found out the value of x to make this expression, this inequality, true. Right? It's like solving the equation 2x plus 1 equals 3. Same idea, except here we have an inequality. So instead of a single value for x, we'll have multiple values, right? An inequality. So to start, we can expand both sides. So that's using FOIL. So first, outers, inners, last. So on both sides, we can do that. So on the left-hand side, we have 3x times 2x. 3 times 2 gives us 6. X times x gives us x squared. 3x times minus 1 gives us minus 3x. 2 times 2x plus 4x. 2 times minus 1, minus 2. And that is all less than or equal to 6x times x, 6x squared. 6x times minus 3, minus 18x. 1 times x plus x. 1 times minus 3, minus 3. Alright, straight away I notice we have 6x squared on both sides of the equation, of the inequation, excuse me. So we can subtract 6x squared from both sides, which effectively cancels those out. Right, because if we subtracted 6x squared on the left-hand side, 6x squared minus 6x squared is 0. Same with the right-hand side. Now I will bring, well, we can combine the x terms first. Let's start with that. So grouping like terms, minus 3x plus 4x gives us plus 1x, or just x. Minus 2 stays as minus 2. Less than or equal to minus 18x plus x is minus 17x. And that's all minus 3. Now I want the x terms on one side of the equation and then the constants on the other. So I will add 17x to both sides, which gives us 18x on the left-hand side. And since we added 17x, negative 17x plus 17x is 0. Oh, I forgot our minus 2. And we're left with minus 3 on the right-hand side. Now, to take the constants over, I could add 2 to both sides, which gives us minus 3 plus 2, which is minus 1. So you could combine these two steps into one step if you want, but I just split it into 2. That's equivalent. Now to get x by itself, we need to divide both sides by 18. Because 18 divided by 18 is 1, so we're left with x is less than or equal to negative 1 over 18. Now you don't need to write that as a decimal, a fraction is perfectly fine here. So if we pick any value for x that's less than or equal to negative 1 over 18, and we put it into this inequality, in for x, this inequality would be true. So this side would be less than or equal to this side. So let's just try it, test it out. That's a good way to check we're right. So what's less than negative 1 over 18? Negative 1, right? That's a nice whole number, negative 1. So in for x, let's replace all of those terms with negative 1. So 3, negative 1 plus 2, times 2, negative 1 minus 1, less than or equal to 6, negative 1 plus 1, negative 1 minus 3. And we can just expand this out. And again, this isn't part of the question. This is just to check that we're right and to understand what it means to solve an inequality. So we're just trying one value for x, but in fact we could have picked any number smaller than or equal to negative 18, and this inequality should be true. So we have negative 3 plus 2 is negative 1. We have negative 2 minus 1 is negative 3. We have negative 6 plus 1, negative 5. Negative 1 minus 3 minus 4. Multiplying these out is positive 3 less than or equal to positive 20. Yes, it is. So by picking x as negative 1, the inequality holds true, which gives us some confidence. It's not definitive confidence, but tells us that, all right, we're probably right. So let's just give ourselves a tick. Call it a day.